Memorize the prefixes that tell the number of carbon atoms in a chain. These 10 prefixes are required memorization in my class. 1 is meth, 2 is eth, 3 is prop, 4 is bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 is none, and 10 is dec. Those 10 prefixes absolutely must be memorized. If we had this structure here in the upper right, this would be associated with which of these prefixes. Let's count the endpoints. 1, 2, 3, 4, 5. So this would be pent, something related to pent. How about this one? If we count the endpoints 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be known. How about this one? This one's a little more complicated because if we start counting from the left, 1, 2, 3, 4, 5, 6, 7, 8. Right at carbon number 8 we have a branch. So do we count 9 or do we go 9, 10? There are other rules that come into play, but in general we're going to want to find the longest chain. So in other words, this chain will start on the left 1, 2, 3, 4, 5, 6, 7, 8, and then it'll go down 9, 10. So this is going to be dec something. Dec will be in the name of this one. How about this one right here? Again, as a general rule, finding the longest chain is the best way to go. We will have occasion to modify that whenever we add certain things into these molecules. But if we just have hydrocarbon material in alkanes, we're going to want to find the longest chain. So here, the longest chain is going to start down in the bottom and go 1, 2, 3, 4, 5, 6, 7. This name is going to have hept in it. How do we name straight chain alkanes? Well, it's very easy. You find the longest continuous chain of carbon atoms, and you choose the appropriate prefix, and the name ends with ane. Here, propane is the name. What would the structure be? Well, prop we know means 3 carbons. There you go. 1, 2, 3 carbons. If we're counting up how many hydrogens are on this molecule, we would count 1, 2, 3 attached to that carbon, and then 4, 5 attached to the middle carbon, and 6, 7, 8 hydrogens total. How about this one? 1, 2, 3, 4, 5, 6, 7. Heptane, sometimes called N, lowercase n, heptane. N-heptane meaning normal heptane or simply straight chain heptane. Obviously that has 7 carbons, and how many hydrogens would that have? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What about if we want to add substituent hydrocarbon groups? In other words, what if there are branches in our alkane? Then what do? Well, first we number the longest chain carbons. We start with the end nearest a branch. In other words, carbon number 1 is the carbon on the end that's nearest to where the branching starts. Second, we name and give the numbered location of each substituent, and we'll show you how to do this. Hydrocarbon substituent groups use the prefixes based on the number of carbons, but they end in ul. So instead of methane or ethane or propane, it'll be methyl, ethyl, propyl, etc. Again, we'll show you these. And finally, we want to list the substituents in alphabetical order. An ethyl group would come before a methyl group because eth is before meth alphabetically. Let's try a couple of examples. let's provide each counterpart here. I've given you the name. I want you to draw the structure. 4-ethyl 2-methylhexane. Let's break this into pieces. Let's draw hexane first. 6 carbon atoms. 1, 2, 3, 4, 5, 6. I can number them from whatever side I choose. I'll number from the left. Whenever you're drawing these, you aren't going to write the numbers out, but I'm just writing the numbers in there so that you can see what we're doing. Now what we need to do is we need to add an ethyl group connected to carbon number 4. How many carbons does an ethyl group have? Eth means 2, so an ethyl group has 2 carbons. So connected to carbon number 4, we have an ethyl group right there. Connected to carbon number 2 is a methyl group, just like that. Now you might ask, if you look at this structure that we've drawn, I drew the ethyl group down here, but how do I know that this isn't the ethyl group? And the answer is we don't know, but it doesn't matter. The point is, off of carbon number 4, there is an ethyl group hanging off. Whether the straight chain goes as I've represented it, or whether it goes carbon number 1, 2, 3, 4, and then it goes 5, 6, with the ethyl group hanging off on the far right, it doesn't make any difference. The name and the behavior are still the same. If we were to count up carbon atoms, we'd get 9. If we were to count up hydrogens, we'd get 20 on that molecule. How about this one down here? If we find the longest chain, I've colored it in green so you could see it. Which carbon in this longest chain should be carbon number 1? Should it be the one on the top here, or should it be the one on the right? And the answer is, it needs to be the one closest to where the branching starts. So if we number 1 from the top, branching starts at carbon number 3, right here. If we start numbering from the right, the branching will start at 1, 2, 3, carbon number 4. So that one is going to be carbon number 1, and we're going to number them all the way to 8, which means this is going to end with octane. What's before the octane? We've got a methyl group, 1 carbon, hanging off of carbon number 3, and then we've got a 2 carbon group, that's an ethyl group, hanging off of carbon number 5. Do we write 3-methyl 5-ethyl, or do we write 5-ethyl 3-methyl? And the answer is we write 5-ethyl 3-methyl because the substituent groups need to be alphabetically written, not the numbers, alphabetically. Ethyl comes before methyl. If we were to count up the total number of carbons, we'd get 11. Total number of hydrogens, 24. Let's summarize. Firstly, you need to have those 10 prefixes memorized. And then, to name branched alkanes, you number the longest chain carbons, starting with the end nearest a branch. You name and give the numbered location of each substituent. Substituent groups end in ul. And then you list the substituents in the name alphabetically.